So yeah, I'm going to give it a couple minutes to wait on Richard, and I'm not sure if anyone else is planning on attending, but yeah, I'm definitely excited about it.
Awesome. Yeah, same here, man. I mean, I think for the longest time I saw the functional channel like dead, and then lately it's been pretty good, good content there.
Yeah, for sure. I was trying to let everyone know at the Elm Orlando meetup last night that we were trying to start a Haskell study group, and everyone's pretty excited about it.
Awesome.
So, what's your background like? Do you have a prior experience with Haskell or functional languages?
No, I don't. It's really an interest in functional programming. I actually I had the awesome I guess time of learning OCaml. I don't know if you heard about that one.
Cool.
I hated it. I don't know why, but it had a very rough introduction to functional programming. I guess I'll put it that way.
Okay.
Um, it was part of our um, I went to UCF, so it was part of our programming languages requirements. Um, and at the time, honestly, like I felt like, what the hell? Like, who uses functional programming? And then at work, I actually started liking like just more interest on it. So
Yeah, for sure. I definitely know that feeling where some of it feels academic, but it's starting to get more practical.
right, right, exactly. And then I found out about Elixir, and then in Phoenix, and I'm like, oh, okay, this actually looks pretty good, and it's makes a lot more sense.
Cool.
Yeah.
Yeah, actually, that's what I've been working with myself. I really like Elixir on the back end, and I love running Elm on the front end. So part of my desire to learn more about Haskell has been about trying to get just better at like functional thinking, like
Yeah.
problem solving or data structures, like the general concept. I think Elm and Elixir, I've just been sort of learning it as I go, which
Hmm.
sometimes is fun and sometimes that's good, but I wouldn't mind having like a better foundational knowledge so that when I go to build something, it's not so painful.
Right. Yeah. I feel like I'm in the same boat. Um, Actually, I found this course. I don't know if you heard about it before. It's in Udemy. And it's basically let me see if I can find the title real quick. It's the complete Elixir and Phoenix Bootcamp tutorial. I don't know if I'm gonna paste the link real quick. But I guess I don't know. I'm trying to use this as like a very yeah, the first link right there. Yeah, as like a very intro type thing. I'm sure it's not like the all.
Yeah, honestly, I've created a couple of small Phoenix applications, but I've been really getting into the channels feature to try and send data over to sockets. And
Hmm.
like I've been looking for someone that knows how to use that really well, so that like I can when I get stuck, I have someone that I can ask.
Yeah.
So yeah, like I think there's a lot of us that are like super into this kind of stuff. We're just sort of meandering our way into it. So actually, I work at codeschool.com, and we're working on a Phoenix course now that should use some of the latest like Phoenix 1.3 features that just came out recently.
Oh, cool.
But yeah, it looks like it might just be you and me if you want to get started. Oh wait, Richard just says he got home and he's jumping on the Hangout now. Okay, so we can give him a minute. I think he had a long drive or something. So yeah, it'll be cool. But yeah, I love this idea of like doing a remote meetup. Um,
Yeah, man.
because I've been hosting Elm Orlando, and I love it. I mean, like I love the physical aspect of it and having everyone live coding and stuff. But for something like this, where it's like a learning group or a study group, like I love the idea that I could just come home and not have to go back out and just
Yeah.
do some reading or learning or practicing and share. Like that's a big part of it for me.
Yeah, honestly, this is an awesome idea, and I think for me it works really well because like I come home at like 4:30, and I got to feed the dog, take the dog out, and stuff like that. So I think it is great. Fits really well with the schedule.
Yeah, I've got the same kind of situation going on. I've got baby due on the way in
Oh,
September.
awesome! Congrats.
So I'm basically trying to organize my life in such a way that I can get things done even
Yeah.
when that happens.
Hey, it's me, Richard. I just wanted to say also that it's good for me as well. Actually, I'll be moving to New York next week.
Oh wow.
It just kind of happened. Actually, not next week, but two weeks from now. So I'll try to stick around for the Haskell stuff for the meetup in the future, but because I still think it's something that I wanted to do for Orlando, but it's it's going to be different being up in New York.
Yeah, I can only imagine. So did you get a new job working with OCaml, or what was it that you were working with?
Yeah. I just got accepted for got a job up in New York doing OCaml.
Cool.
It's a startup, so it's gonna be real busy. But I'll see what I can do about still showing up to the Orlando thing, especially since it's remote. Like this is nice actually.
Yeah, for sure. So I tried to put together a little bit of structure for us, just to get an idea of like, I wanted to ask you guys about your goals for learning Haskell, why you're looking to learn it, and maybe some goals for these meetings if we're going to keep doing them moving forward. A couple ideas like, did we want to do presentations or sharing, or like have a book club kind of approach, or like we talked a little bit about doing practice problems, and I think that's a really good idea. Maybe something about like the frequency of how often we want to do this, or scheduling. I really like I said, I think we're all on board with this. Like remote meetings are pretty much ideal for me to just be able to like hop in and not make a huge ordeal out of it. But yeah, like I guess starting from the top, like what are you guys looking to learn out of this stuff?
So for me, what I really want is to sort of keep promoting functional programming in the Orlando area.
Cool.
I feel like there's a lot of other communities that traditionally have larger show up, and I kind of just wanted to help seed and start something in Orlando. So with that being said, I think Haskell's a great choice as a kind of like a common language we can all rally around, and I think we should just start from the beginning. Like do a lot of practice problems and get people up to speed with it. I don't know what everybody's level is at, but just take it step by step and see what all the fuss is about. Why are people talking about Haskell? I think it's a great language.
Yeah, I love that idea of starting from the beginning so that we can encourage people that maybe are on the fence about it. And I think right now the community is a little fragmented. So like there's a lot of interest, but it's kind of all over the place. And yeah, I think we're just looking for a place. Like there's definitely enough interest to sustain something like this. It's just a matter of getting it organized enough to have everyone in the same place.
Right. So any other ideas? I think I kind of said my part.
Yeah, I mean, I would agree with you too. For me, it's more of it's an interest. I have a lot of interest in that area. It's a curiosity, I guess. Um, and I think I was talking earlier about my first introduction to functional programming was in OCaml, through like the UCF programming languages course. And unfortunately, it wasn't a great introduction. I think I hated functional programming for a little bit, and then as I'm working in the industry, I started kind of levitating towards it, and I think it's a pretty interesting way of solving problems, um, like more elegant. But yeah, I would agree. Like I want to kind of be part of like the beginning culture here in Orlando about that, and yeah, if it's Haskell, then Haskell it is. I wasn't aware that like we already had a one common language that we wanted to kind of come around. Um,
Well, so my opinion on it is it's like really hard to sort of quantify what is a functional programming language, because there's several different kinds, and I feel like people who come from a Lisp background might say, oh, Lisp is functional programming, and people who come from an Erlang background might say, oh, Erlang is functional programming, and then you come from the ML background, you got Haskell, you've got standard ML, OCaml, and they're just vastly different languages. Even within even between Haskell and ML and OCaml, they're quite different. That being said, the differences are much smaller than like the differences between Haskell and Lisp, for example. So what does it mean to be a functional programming language? And so I was thinking about like, I think a common language that we could rally around would be Haskell, just because it's quite popular, it's quite extensible, it's purely functional. So it's kind of like getting a deep dive into what it really means to be functional programming, and then from there you could branch out and sort of explore the rest, either on your own, or we could turn this into like a Haskell and Friends kind of meetup.
Gotcha.
I think you touched on some points that were really relevant to me, is that, what constitutes a functional programming language. And for me, one of the reasons I really have an interest is that I've seen, when I first come across a new way of thinking or a new mental model. So I was studying Elixir, and pattern matching was a little new to me, and I found it really difficult to actually understand. But then I would see it in Elm, and then I'd see it in Elixir, and I'd go back and forth, and I would just be like, oh, this makes total sense. Like I could see it from two different perspectives. So part of my desire or my goal to learn Haskell has a lot to do with my interest in getting a different perspective, because I'd like to just get a better functional problem solving approach, so that things are a little easier on me and I'm not just like stuck in old patterns of what I'm accustomed to from working with Ruby and JavaScript for so many years.
Right. And sorry. The cool thing about Haskell is that it's purely functional, so it kind of forces you into that paradigm of thinking. Other languages like OCaml have like a trap door where you can say, hey, let's do this imperative, and it won't complain. It'll be happy to do it. So if the goal is to learn functional thinking, I think a great approach is to just dive in.
Okay, yeah, that leads us to our next point. Like, what would be the structure for these meetings? Do you guys want to follow a focused, like, sort of curriculum, or do you just want to get together and work on some practice problems? I know Richard brought up the fact that it would be nice for us to use something like Replit, where we've got like, we wouldn't have to have people set up their local environment. It would just be like a working, usable Haskell environment in the browser.
I think that works great. If for especially for like new people who don't necessarily have a Haskell set up on their computer, I think it's fine if we're just going to go through some smaller problems. But once people want to, develop larger things, then I think it would be beneficial to maybe we could set up like a tutorial page for getting people set up on getting their environment set up. And then the other problem that we have is like, all right, so what if people are coming from different operating systems or different environments? Mm-hmm. Then I think if the goal is to learn Haskell, then we should just learn Haskell and not learn how to install it on 5 different systems.
Yeah, I totally agree. I think Richard had shared an article about teaching Haskell and where the focus should be and where it shouldn't be. So like, I think a lot of that kind of stuff could be a little superfluous, and we'd want to focus on the main educational aspects of it. So.
Yeah, and if the group eventually got big enough that we could sort of branch it, then we could have some like subgroups that set people up if they had questions, or if we ever evolved to a point where we did have face-to-face meetings, then certainly there should be people who can help new people set their environments up. But I think right now, I think the goal is, hey, let's just dive in, let's just do it.
Yeah, that sounds good to me too. Like, so what does the first step of that look like? Are we gonna because I know for me, one of the things that tends to help is to pick a book and then just work my way through it, and then start either building projects or like working through practice problems. Is there like a first step that you'd want to take in terms of just like us as a collective?
I mean, for me, I think just working through like the 99 problems
Cool.
would be really good. But some other people mentioned Exorcism or Code Wars or you know these kinds of places. They also have good problems. And then it really depends on like where we are as a community. And if 99 problems is too easy, then we can move on to other things. I'm fully open to that as well.
Cool. Yeah, I actually took a cursory glance at this, and I was like, oh, this is going to be really hard. And now that I look at it, it probably took 2 seconds, and now I'm like, oh, okay, I think we could totally do this.
Yeah, a lot of them. So I personally haven't done all of them, but at least for the first couple of them, they're just really like, let's like writing a function to like, reverse a list, for example.
Yeah.
But let's do it like the purely functional way instead of the allocate a new array and then like walk it backwards or whatever. So we could just start with that, and then that would we could learn about recursion and pattern matching. And if it's too easy, then we can move on. If it's too hard, we can take a step back.
Cool.
Really don't know where the community lies in this space.
I like that idea of just getting started and like diving in, and then we iterate on that. Like, so we just, we figure out what's working well and what's not. But yeah, Richard, do you have anything in mind for what you wanted to sort of pursue with this first meeting?
I think we should just well, does everybody have access to the REPL?
If you want, I think, can you share a screen too? Like, if I unshare my screen, are you able to?
Probably. Let me see. How do I share a screen?
Hey guys, is the GitHub README that you're creating there, is it available already?
It's just a GitHub gist. I can
Just
post it in the Slack room.
awesome. Because I don't think I have the links right
Okay.
now. Yep, got it. Thank you.
Can somebody, let me see, how do I share my screen on here? I actually don't, I've never used Google Hangouts before.
Is there, to the left, do you have a toolbar?
Yes.
And then is there a chat at the top and then a green one that says screen share?
Oh, yes, I see it now.
Cool. I wasn't sure, like, it took me like 3 hours this morning to try and figure out what Google Hangouts is and what YouTube is. And
what is YouTube? Okay, is this working out?
Yeah, I think you got it. Oh,
Okay.
wait, it came up for a second.
It says I'm screen sharing.
Okay, cool.
If I open a new tab, can you guys see that?
Yep.
Okay, so let's, what is it, REPL it? Haskell?
Hey guys, sorry I was late. Ran longer than expected.
It's all right. We're just getting started. So here we got the REPL. Let's see, and then we need to get the questions. So Haskell 99 problems. And they've been split apart into 11 sections. And the first 10 questions are on lists. So forgive me if my Haskell is not super idiomatic. I've kind of gone to town with OCaml lately, and there's a couple things that are a bit different. So I might be writing Haskell in OCaml, but if it type checks, it should be okay, right? Okay, so the first one says we're going to make a problem. We're going to write a function to find the last element in a list. So the first thing we should probably do, let's write down the type. So we'll have a function called myLast, and its type is going to be a list of stuff. to that stuff. So, oops. So a list of objects to whatever that object is.
So it takes in a list of anything and then it returns the last item in that anything list?
Right. So it should return. So yeah, if you don't know what this little a is, it's something called a type variable. And what it means is it's basically the same as like a generic. If you're used to like Java or C++, it's like we have a list and the list has elements inside it of some type, and that is the type. So we're going to do my last, and let's see what happens if we have an empty list. Yeah, if we have an empty list, we have nothing to return. So are we screwed? So I think what we should do then in this case is, if there's no way, if somebody passes us an empty list, then we should just return nothing.
Okay.
Right? So that would change the signature from list of A's to maybe of A.
Okay, cool. Yeah, the one good thing is that I've had some experience with Elm, and the syntax is very similar.
Yeah.
I think it's just a single colon instead of a double colon. The rest of it looks exactly the same.
Yeah. So if we have an empty list, well, there's no last element. If there is a list with one element, well, then we just return that. And if we have a list with multiple elements, we want to throw away the first element and get the last element of the rest of the list. Do you have any questions about this?
So this is recursion and function overloading at the same time?
Sorry?
Like, are these function declarations, so this is 3 different function declarations, right? And they're overloaded?
In Haskell, what you can do is it's something called pattern matching, and you can do it at the place where you define your function.
Okay.
So in Haskell, the equals sign doesn't necessarily mean like assignment. It actually literally means equality. So whenever you have this symbol, which is my last, followed by an empty list, then that will return nothing, right? That can be replaced by nothing. If you have my last followed by a list with a single element in it, then we return that single element. Actually, I just noticed a bug, because whenever we have a single element in the list, we need to tell it to return that as a just X, because we're returning a maybe type. So we found it. That's the last element. Yeah, so it's kind of like when you define a function like this, then Haskell will choose whichever version matches whatever data you pass in. So if you pass in an empty list, it'll pick this one. If you pass a list with a single element, it'll pick this one. And if you pass a list with multiple elements in it, so X being the head of the list and X's being the tail of the list, then we're going to hit this case. And this case says we're just going to call my last on the rest of the list. And so it's kind of like recursively whittling it down. So let's try this. Let's try running it. Do I have a parse error?
7.
On line 7. That doesn't make sense. Well, what if I comment out the...
Is it that the recursive call needs to be calling just? No, that doesn't make sense.
No, I don't think so.
Does the XS need to be wrapped in a list? So like you need square braces around that?
No, you shouldn't need the square braces, but I'm wondering if maybe you need to do this.
Okay.
Not in scope main. Okay, now it's compiling. Now it's complaining that I don't have the main.
Okay.
Okay, so let's do this. Main, which is of type IO, and then main is going to be well, let's
I think you could just do and then call my last with an example. This would be like maybe just our unit tests, basically just give it an empty list and then
yeah, let's do my last with an empty list. That will give us a some maybe type. So then we have to do case. So case my last of that. How do we do this? Is it of?
I think
Of, and then we say, it's kind of been a while since I've done Haskell. Case that of nothing. Is that right?
that looks
Am I
right.
missing? Yeah.
I think
Nothing, and we're gonna maybe put Sterling nothing. And if you get just something, then we say put Sterling of show X. Okay, so show. So that means by using this show function, we're saying X is something that is showable. So we should put that constraint in this function signature and say that A is showable. I think that's right. I guess the how do we do this? Run. Man. Haskell case.
It's just complaining that you haven't imported the list type.
Oh, yeah, sorry. This is a
okay.
OCaml-ism, sorry. In Haskell, the list is denoted this way. Maybe that should fix it. Run. There we go.
Cool.
Cool. So let's do this then.
Actually, yeah, I have a question. I think in Elm, you import list and it gives you, well, actually, I think it just comes with the default library, like the base libraries. And you could do like list dot last, or no, I guess there's list dot head, which would return a maybe or you know, just the item.
Right.
In Haskell, is there a list library or like a package that just comes with a bunch of helpful list functions?
I believe so, yes. Go ahead. You were going to say something?
I think data.list.
Right, data.list.
Okay. So yeah, like reverse, for instance, it looks like, just from the example I'm looking at, it looks like you could just use reverse on a list without calling like list.reverse. Is it just baked into the base library?
Like the prelude? The prelude includes a lot of functions, a lot of like convenience functions.
Okay.
But some things you do need to import. And when you import them, there's two ways of importing. You could do like just import, and it'll import all the functions inside there and put them in your namespace. Not in namespace, in your current scope. Or you could import qualified, which is similar if you've used Python to like just import by itself. And then you can rename it, like you do import blah, blah, blah as whatever, or in Haskell you would do import qualified data.list as L, I think is the syntax. So someone correct me if I'm wrong.
I think that's correct. I just went through a tutorial right before this, and that was exactly what it. So I think what happens is, like, if you use that qualified, then you're not like polluting the namespace with a ton of functions.
If you just do an import, though, it's essentially like the Python equivalent of from list import star, which really sucks. I think that's one of the things I don't like about Haskell, but that's just me. I don't like the import everything by default. Okay, so we don't need this right now, so I think this should work. Let's test a couple other cases. Let's do ABC, DEF, and if we run it, we get DEF. Cool. So let's go back to our problems. Does anybody have any questions?
I think it looks good. It's working, so that's a plus.
Yeah, and I'm. It's kind of been a minute since I've done Haskell, so apologies if I run into some issues.
I'm definitely relearning as well. So
I'm relearning. Do we want to work on number 2?
Sure, let's go for it.
Okay, so we're looking for the second to last element of a list. So we could do my but last is going to have the same signature. And so what we could do, there's a couple different approaches we could take to it depending on how efficient you want to be. So if you have an empty list, it's nothing. If you have a list with a single element, then it's nothing. Oops. If you have x cons y cons the rest, so let's just call that x's, then what we care about is going to be x.
So it's second to last?
I think so, yeah. Is that what it is? Find
Okay,
right? And I think that's actually wrong. Hold on. Yeah, that's actually wrong. So what we need to do is say this, because what we want is the end of the list. And technically the y doesn't need to be named. Then my but last x's is going to be my but last x's. It works. So if we change this to my but last, run, we get a parser. Fun.
You need to wrap those arguments in parentheses like we did on the first one.
Thank you. Here we go.
Nice.
Cool. So we got what we were expecting. And if we pass in a single element list, then we get nothing at all. And if we pass an empty list, we get nothing at all. Now, another thing you could do, another way you could implement this would be reverse the list, pop off the first element, reverse the list again, and then call my last.
I'm happy that you implemented your solution first, because that's what I was going to say to do, and that would have been that would have taken a bit more time and seemed a little less elegant, I guess I would call it.
Sure, but let's try it. My but last apostrophe. Well, I don't know if the type is really necessary, but let's put it in there.
So I know in Elixir there's like a pipe operator. Is there something similar to that in Haskell?
There is. The Haskell idiomatic equivalent is actually the composition operator, which is a little bit different, but it maps more closely to the mathematical definition of composition. I'm I'm not sure how I feel about that operator, but I kind of prefer the pipe operator myself. But let's see how it works, and then we can talk about it. So my but last. If we have an empty list, we're returning nothing. My but last. If we have a single element, we're still returning nothing. And if we have anything at all, then what we can do is say we're going to reverse. Is that how you do it in Haskell? I forgot the. Can I type it in here? Reverse.
Yeah, I just tried it out. I think you can do a reverse list.
Do this. T
as long as you're giving a.
Hey, that works. Okay. So we can do reverse, and then let's say we pop off the head of the list. So we'll do. I'm going to compose that with tail. And then we're going to compose that with reverse. And then we're going to compose that with my last. And then what you would do then is, I don't know if any of you have seen the $sign operator. Basically, it's a function application. In other words, it's basically like saying we're going to, normally you would have to like wrap this up because this entire thing here is now a new function. And then if you want to apply this, you would then say pass it the argument. You can do that. Or you could use this infix operator, which is also very common, to apply the new function on the left to the argument on the right. So the way that you would look at this is a function. It's the equivalent of like f, right? Function, and we're applying the arguments. And then because it's function composition, this x is actually going to go in. First, it's going to hit this function, and the result is going to be piped into this function, and the result is going to be piped into this function, and finally into this function. So let's see if this works.
I think on line 15 you're missing the prime. Yeah, there you go.
Thanks. Yeah, I noticed that at the very end. So let's do A, B, C, E, E, F, G, H, I, H, I, J, K, L. So we should expect to see G, H, I. And if we run it, there we go. We've got G, H, I.
Looks good.
Cool. So we have two ways of solving that one.
I've got another suggestion.
Sure.
Do the first part, reverse it, and then just take two. But then it's still a list is the weird thing.
Yeah, so reverse it, take two, and then
take the last, and then take my last.
And then tail. So my but last. I don't think we need to put the function signature. So if we have an empty list, it's nothing. Otherwise, if we have a list, we're going to say reverse, and we're going to take two, and then reverse, and then head.
I think if you just take tail on the take two, right?
I think if you take tail, you'll actually get another list. But yes, you could do that.
Is there a single operator to take like a list of one and turn it into just one, or like error? Does that make sense?
Yeah, that's what head is. So if we go here and we do head of one, we get one.
Yeah. So yeah, got it.
The only problem with this function is if you have a empty,
Yeah.
it'll actually throw an exception.
Yep.
So the it's not quite a safe function.
Definitely.
I think from what I've heard, just reading around the internet, head and tail are what's known as incomplete functions. I think that's the term I've heard.
Huh.
And people generally suggest avoiding those and maybe implementing your own that uses the maybe wrapper.
Right. That makes sense.
But for pedagogical reasons, we'll continue to use them here. Cool. So tail, on the other hand, if we look at the type of tail, it's the other way around. It takes the rest of the list and returns it. So while head takes the first element, head takes the first element out, tail just returns the rest of the list. So, yay. Okay, let's move on. All right. So find the kth element of a list. The first element in the list is number 1. Okay. So let's do this one together because I don't know if I'll be able to do this by myself. Element at, and let's write the type signature first. Let's take in a list. Let's show first a list of A, and we have an integer telling us which one we're going to pick, and we're going to output a maybe A. So the first thing we can do is anybody have any suggestions?
Well, I'm trying to avoid using tail, but again, take the what are you calling the value you're passing in? You haven't named it yet. Take whatever integer value you're taking in, and then tail it. But again,
okay. So we could do
naive implementation.
our list. Sorry, x's are k, and then we're going to call take on x's.
Yep.
But we've got to take a certain amount of them. So we're going to take k x's, and then we can reverse it, and then get the head out of it. And then since this is a new function, we need to wrap it in parens or use the $sign. Let's try this. Element at.
So is it going to be 0 index or just from?
Oh, yeah, that's right. 1 index. So the k is going to have to be, what is that? K minus? Hold on. If we pass in a 1, we take 1. No, I think we need to do that.
Yeah, I think it's perfect.
I think it's fine.
It's actually a pretty expressive way.
Element at x, if we say 0, or let's say k. I believe there's a way of setting up a guard on k. Let me skip that for now. Let's just see if this works for now. Element at, let's say 1, we should get ABC. So what do we get? Couldn't match expected type with actual type. Oh, right. Yeah, because we're not putting this inside of a maybe right now.
Ah,
Now let's take the maybe out. And what do we get now? Oh, well, we're not in maybe anymore, so we don't need to do this checking. So let me comment that out. So we do element at, oh, sorry, just copy that. And then what's a good way of stir and show? I should do it. Run. It's on line 21. What? These line numbers don't make any sense.
yeah, it's like it's off by some constant.
It's applied to too few arguments. So take, so if we did head dot reverse dot take, that should be function. Oh, right. This thing is now stop. Okay. T of take. All right, I'm going to pull up my own interpreter. So we have T of take. So we do.
I think you might be sharing your browser window, but not your.
Oh, yeah, you're right. Thank you for pointing that out. Let me see if I can change that. Entire screen. Share. Can you see the terminal window now?
Yeah, looks good.
Okay, I'm going to make the screen a bit bigger so we can get. We're doing T of take. And if we pass in a number, let's say 1, now we're list to list. So we're going to take 1, or it'll be take n, but let's take 1 of I'm going to reverse the list. Wait, is that right? I'm going to take a certain amount, reverse it, and then take the head. So this one should evaluate to an A. So it's C list to C, which is what we want. And so if we say let eighth equal that, and we have a function called kth, which, oh, my fault. Kth should, here we go. Kth of 1 is now a function which takes a list and gives you the kth element. So let's do kth of A, B, C, D, E, F. The first element, and we should get ABC. 2, we should get def. If we do 3, we should get an exception. Oh, look at that. So that's incorrect, because if we do take 3 of ABC, D, E, F, then we'll just get.
I did not know that.
Interesting.
That's really weird.
Yeah. So I guess if we try to take more from a list than it has, then it'll just return the whole list. And I just learned that too. Cool. Are we all comfortable?
Yeah, I'm good.
Good. Should we move on, or do we want to? Let's move on.
Yeah.
I think I lost my.
I'm just curious, is everyone here, actually, or all two of you, use, I mean, obviously you have, I'm assuming you've used Haskell before as well. Who else is here? Gabriel.
Yeah, I'm just trying to follow along. I haven't used Haskell before. I only use OCaml, so it looks sort of similar, but
It looks similar, yeah.
yeah.
Yeah. Okay, cool. Just curious.
Yeah, in OCaml, the type signatures would be backwards, but that's just OCaml for you. Okay, find the number of elements in a list. So let's create a function, elements, num, oh, it's length, my length.
So does this mean do it without the built-in length function?
Absolutely. So, right. So if we have an empty list, oh, let me do this because I think this is going to be more than one line. So you can, in the GHCI REPL, if you start with a colon and a left curly brace, it lets you input like more than one line. So you can use it for pasting code or writing stuff that is like a block of code.
Cool, I didn't know you could do that.
Yeah, and you can close it with colon right curly brace. So here I've done nothing. So let's do this. So let, I think I have to do let here. Let me try it without. My length, empty list, 0. My length, x colon x's. Right, we need to put that in friends. That's going to be 1. Actually, we don't care about x. 1 plus my length x's. Okay. Let there. Ooh, how would I do that in the REPL?
What exactly?
I want to define a new function, but I have to use let in the REPL because for whatever reason, GHCI forces you to. Let's try this then. Let's do this in Vim. Okay. Okay, so my length is a function that goes from list of anything to int. My length of an empty list is going to be 0, and my length of something and another is going to be 1 plus my length of the rest of the list. So this is a kind of a, oh, we need a main equals put Sterling show of my length of 1 to 10. So this should have 10 elements, I believe. We run Haskell. 10.
Cool.
Cool. Oh, I didn't have it. And if we did empty list, we get zero, right? And if we did 1,000, 1,000, and if we do infinite, we should get a Stack Overflow.
It might actually be lazy. I guess you're asking though, so.
Yeah, so I think I've killed it.
So is run Haskell an alias for something else?
Yeah, it's just no, it's not. It's actually, if you install the Haskell like GHC distribution or whatever, it comes with this script called run Haskell, which lets you run without having to compile or anything. It just runs it. I'm using it because I don't want to set up a project. I just want to run one file. Okay. How do I hide this thing? It's driving me nuts. Okay.
I feel like full-dar would be appropriate here.
Oh, sorry?
Are you familiar with full-dar?
No. Can you explain?
Yeah, it's again, been a while, but it's a good way of handling an accumulator use case.
Oh,
So-
yeah. Oh, fold-R. Yes.
Yeah.
Yeah, absolutely. You totally could do that. So one problem, I'm not actually sure if this is being optimized away. But one problem that we have here is that our function is not tail recursive.
Right.
So does everybody know what tail recursion is?
Vaguely. I've had some experience with, I tried to work through the little schemer with Elixir, and then like halfway through I realized that you could just use libraries that abstracted away all the recursion. And
Yeah.
basically gave up after that.
Right. So tail recursion is basically an optimization technique that you can do in Haskell, or that Haskell compiler does whenever it encounters a whenever it encounters blanking out. Whenever it encounters a recursion happening as the very last statement in the program. So what we have here is, because we have our recursive call right here, but over here we still have something that's not complete. So essentially what we're doing is we're expanding, and we're saying 1 plus, let's put it over here, 1 plus, and then 1 plus 1 plus 1, like that. And so this thing keeps kind of expanding forever. And my guess was that it was going to give me like a Stack Overflow of some sort. Maybe GHCI has a better optimization for this case, but essentially, it's never finishing the evaluation. It just keeps growing. And what Haskell will do is actually build up a whole bunch, like a thunk, and you have the lazy evaluation, like the stack for that thing keeps growing forever. So let's not do that. So one thing you could do is say, all right, let's use an accumulator, right? And what you could say is, all right, if we have an empty list, let's just return the accumulator. Otherwise, we're going to call my length of x's, and then the accumulator is going to be increased by 1. So now this is a tail recursive function because, hey, this is the last step that's happening before we recurse. So this thing can be essentially optimized into a while loop. And then we won't have any tail, Stack Overflows.
So this would be doing the same thing as fold R. Like if we pass the 1 as the starting number for the fold.
Correct. Yes. This would be basically our own version, our own implementation of fold R.
Okay.
So in this particular case, we need to specify that we int as our second parameter. So we start my length with int of 0 as the initial value, and then we say 10, and we run Haskell. What did I do wrong? Couldn't match expected type int with actual type list on line 5. So, oh, I put the argument out of order. Yeah.
Actually, I was going to ask about that. Is it common practice to add so like let's say you have a take n function. Would the n be the first argument or the last one?
Well, folds takes the list last. That's one data point.
Okay.
Let's have a look at the definition of fold.
Fold R.
So there's two. There's fold L and there's fold R.
Yeah, I always forget the difference and what they're for.
Yeah, that's a good question. Actually, I had an interview back in January with another company, and they asked me to implement a fold R at the interview, and I was like, I usually just use fold R. Right. So let's see if we can figure this out. So let's look at the type declaration here. So if we're looking at fold R, let's just start with a fold R since that one was brought up. The first argument is a function that takes an A and a B, and then it outputs a B. And then we supply a B, and then we supply a list of A's, and then essentially we're going to collapse that list and output a B.
Yeah.
So the weird thing with some of this stuff is like I feel like I have a good enough understanding to use it in practice, and then when I see the type signatures, I'm like, there's no way that I could fit all those letters in my head.
Yeah. Yeah. So I think the what you could do whenever you have that problem is just sort of take it one step at a time, right? Follow the types. And I recently had a problem. I was when I was working on that React ReasonML thing, where I was like stuck on some dumb like type error, and I didn't really understand what I was doing, but I figured out that if I just followed the types, then things kind of worked out. So, and eventually I ended up writing it correct because the types kind of forced me to. Right, so fold R. So let's we're gonna fold. So let's look at the signature for the plus function. Our plus function takes an A and returns an A. Well, that's great because here we have an A and a B, and we can just replace B with A. So now we'll have fold R. If we apply the plus function to fold R, then all those B's should turn into A's, or all the A's will turn into B's, whatever. And then we supply an initial value, 0, and then we have a list. Actually, what we wanted to do was +1, right?
Right.
+1. So something's not right here. Something's not right. Actually, what's the problem is plus is going to add all those numbers together. So if we say 0, 1 to 10, we're going to get like what, 55?
This would be like
That's true.
Yeah,
Well,
5. So our
yeah.
function is actually wrong.
Yeah, I have an implementation. I just wrote a lambda that added the accumulator. Basically, it took the accumulator and ignored the input value.
Yeah, so we have A, B, and then you said what? B is the accumulator, so we'll do B plus 1.
Yeah, you can even just ignore the A. Yeah.
That works.
Yep.
Cool. And if we do fold L, and we'll get something different, because the accumulator is on the other side. So accumulators on the left.
It's very interesting. There must be some sort of computational consideration here.
Yeah. So I don't have the answer up front, but if I remember correctly, the fold L is kind of like your traditional, like, we're going to start on the left side of our list and sort of apply each element successively to our accumulator. And then fold R, if I understand correctly, kind of goes to the end of the list and kind of works backwards. So we don't see this issue with numbers because numbers are, addition on numbers is associative. So
Right.
1 plus 2 is the same as 2 plus 1. But I wonder what would happen if we did it with like string concatenation. I wonder if we get. I don't know. We can try it. So let's try this. Fold R. Concatenate 2 strings. Our first string is going to be empty. I'll do ABC, DEF, and GHI. Will we get something different? No, we don't. So it's not changing the order.
It could be executing in a different order, but still.
I think that's what it is. Yeah.
Yeah.
I think what it is it's kind of like the difference between like a left associative function versus a right associative function. So it's applying like it's kind of hard to explain.
It's strange that if that's the only difference, that it changes the order of the accumulator and the input value. You know what I mean?
Yeah, I think they do that on purpose.
Because it's folding right versus folding left, I guess. It's sort of metaphorical.
Yeah, I think so. So, right, how could we? Maybe we should just look at an implementation of fold R and fold L. Go to learn you Haskell.
There's a great resource too, if for you guys who haven't used Haskell, Hugel.
Oh yeah, Hugel. Let's look at Hugel.
Which you can supply type signatures. You can search type signatures, basically.
So let's say we wanted to know some function that looks like this. We say MA, A to MB, MB. Pretty easy to find. There it is.
Good old bind.
Good old bind. So let's check out.
It's a cool thing. It's helpful. I don't know if other languages probably have similar things.
I don't know. I haven't found one for OCaml.
Really?
I guess I really haven't looked. This Hubel is really useful. I've gotten into a situation where I've like looked for. I was like trying to do something using the traverse type class, and but I didn't know that I was using the traverse type class, I just typed like, I need something to do this, and I typed it in, and it's like, oh, you mean you need to use this like crazy abstraction that you never heard about, and then I tried it and it worked. Magic.
I always feel like I learned something new about the universe when I learn Haskell.
Yeah, I'm with you on that. So let's find the fold R, because I honestly am not able to explain this succinctly.
There's probably a fold section or something.
Probably in the recursion.
We're also probably going a little off the rails. I don't know if we want to stick to our format of 99 Haskell problems or.
Yeah. What does everybody think?
I'm okay with solving whatever you guys are looking to solve here. Stick with it until we get it figured out right.
So, way to go.
So just to recap though, like what is it that we're looking to accomplish here? Is that fold R, we're just looking for the difference between fold R and fold L?
Yeah.
Okay.
Yeah, let's try to figure out what the difference is between those two. So in fold L, we have our accumulator. We have an X, the value. And so kind of like a list comprehension, we're popping off X's and putting them here. And then we're applying them to this function.
Right, this is in the context of summation.
Correct. So we're popping off an X and we're adding it to the accumulator and we're doing a sum. So it's like we start off with 0 and then we do 3 and then the 3 becomes the new accumulator and then we do 5 and that gets added to 8, becomes 8 and then 8 becomes our new accumulator. And then we pop off with 2, et cetera, et cetera, et cetera, until we get to 11. But if we do the fold R, is there a similar image for fold R?
Come on,
it works.
Mirroring. Don't let us down.
It works in a similar way. Only the accumulator eats up the values from the right.
It might, yeah. It might just be more applicable in different use cases. Like the difference might matter more.
I think so. But there was one, I remember reading one caveat that I think if you use fold R, you can't use it on an infinite list because you'll never.
Right. It'd have to reach the end of an infinite list before it could apply the accumulator.
Exactly. Okay, let's get back to it.
It'll do its damnedest to try.
Yeah, it will. Don't complain. It's like this type checks. All right, let's reverse the list.
So if Haskell is a lazy language, does that mean that we would just be lazy and use the built-in reverse function?
Yeah.
All right, I had to throw a joke in here at some point.
I reverse. Hey, we did it.
Oh, I can't even do that right.
There we go. You have to type let before it when you're in the REPL.
It's like a request to be lazy.
My reverse takes a list and returns a list. My reverse on empty lists is an empty list. My reverse on a list with things inside of it is going to be my reverse on the things to the right concatenated with our list. Just backward.
Yeah.
This is not a very efficient solution.
Actually, this was my solution on exorcism, and yeah, I found out the hard way based on their feedback system that someone was like, "This is not efficient." I was like, "Oh God,
not efficient." So let's check it out. Let's do my length. Let's start off with not my length. My reverse 1 to 10. Okay, no problem. We can time it too. Okay. Let's do 1,000.
I'm not sure if it's just me, but I think your screen's frozen.
Oh,
Or
think
you're
it's still
in the
working.
window. Oh, there you go.
right. We're just going to do the computation and then return nothing. Oh, that didn't work. How do I just throw away the value? My reverse is going to return a list. Oh, you know what? I think I have to do I care about the result. Return nothing. Let's see if that fixes it.
Is it lagging for you guys? I might just drop if it's just me. And then,
I'm sorry. I think I might be going a little fast. I need to slow down.
no, I'm pretty sure there's just lag, at least for me. Anyone else? No?
Well, Alex, before you leave, is there anything that you thought went particularly well with this, or what would you like to see for the next one? If we.
Oh, sorry. I'm just gonna drop and rejoin because Hangouts.
Oh, okay, cool.
Hangouts is just not good sometimes.
Okay. So yeah, I really like this sort of practical doing format as opposed to just discussion.
Yeah, I do too. And you know what's cool about it is, you know, as we go through and we run into all these problems, you know, like, oh, why isn't this compiling? We can, you know, together we can figure out, you know, why is this not compiling, and learn to read the error messages as well, because that's an important skill.
Some might say that's the entire point of Haskell is to look at error messages.
Okay, so what am I doing wrong here? My reverse is returning a list, but main expects an IO.
This is true.
And it expects an IO of nothing, like a unit. So if I do that,
You want to just use a let expression to assign the result of that to a value and then return something?
so hey, that worked. Yeah. Okay, so that was 1,000, a list of 5. Oh, but you know, there's actually a problem. I think that is not even being evaluated because of the laziness. Let's try something. Let's try to reverse an infinite list. Hey, we did it!
You did what?
An infinite list.
We've cracked, you know, cold fusion, infinite energy, guys.
Infinite energy. We did it. In the time span that it took to start the Haskell VM or whatever. Okay, so we actually need to evaluate this thing. So let's try. How do we get this thing to evaluate? Well, what we really need to do is somehow put this thing inside of the monad. Oh, scary word. So right, we all know that Haskell has monads, and in order to do anything in main, we have to sequence like a set of commands. But this part here is outside the monad. So since we're saying, hey, we don't care about this computation, Haskell's laziness says we're not even going to try to evaluate it, and we're just going to return. So we need to somehow trick Haskell into trying to evaluate this thing.
You could just put it. I would probably do it. Put strip.
And we'll put it all over the screen, and then we'll never see the timing.
I see.
We'll just work my screen. Do this. Okay, you know what? Let's just put it on the screen. Put so okay. Okay, that took 600 milliseconds. Let's add another. See, I think it's gonna, the result's gonna be skewed by the printing, but we got 7 seconds this time, which is way more than the last one.
Yeah.
The problem that we have is lists in Haskell are built up using like this cons operator. So this colon is our cons operator, and on the left we have an element, and on the right we have a list. And so when we do our reverse function this way, if we want to concatenate two lists, what happens is the first list has to get traversed all the way to the end, and then Haskell is able to like sort of stitch it together with the list on the right. So since we're recursively calling a big O of n operation, you know, it's going all the way to the end every single time. We're actually bounded by like n squared. I think this is a quadratic time complexity function. Anybody disagree?
I think it would be in log n.
You think it would be in log n?
Just, well, my computer science is rusty.
I think it would be the other way around, because the first time, okay, so let's kind of step through it, right? The first time we give it a list of like size 10,000, it's going to take the first one, put it over here to the right, and then it's going to recurse into the first, the second half of the list, or the tail of the list. When it recurses, it's going to do the same thing. And so essentially, you're just going to get a whole bunch of x plus plus, sorry, let's say x1 plus plus x2 plus plus x3 all the way to xn, right?
Sure.
And then what Haskell is going to do, I believe it's going to right associate. So we're going to have essentially like putting parens here, and then putting parens here. And we're going to get here. Is that right?
I honestly don't know.
This kind of looks like it would be right.
I've always the phrase Haskell is right associative by nature seems to sound right to me.
I think that sounds right. So what we would get is two lists, which would get concatenated. That. And then we get to here. And then this one is just a single element list, so then there's nothing to traverse. And that becomes that, which then gets turned into that. And then we continue evaluating till we get out here. And we get that. I don't know. That's a interesting problem. I actually don't know the answer to that. My gut instinct tells me it's quadratic, but what we just did on the screen seems like it would be linear. If anybody figures out the solution by next time, I'd be glad to hear it, or maybe I'll research it and talk about it next time. Okay, let's move on. Ooh, that's right. Sorry, guys. Oh, we didn't. Oh yeah, we did run it.
Classic.
Is palindrome.
Oh man, this is gonna suck in Haskell. Well, maybe not. Break it into lists, reverse, compare, something like that.
Good question.
The thing that would really ruin it, you'd have to do some even odd pattern matching, I guess, or guarding, because that would really mess up that algorithm. Does the how do I say this? The gist of what I'm saying, does that make sense? If you
I think so.
take half the length of a string in this case, and reverse the second half, and then do a comparison, something like that.
I think if you just reverse the string and it's equal to the string itself.
True.
Yeah. Good point.
Yeah, that would work.
I could swear I've done this on exorcism, but I can't seem to find my own solutions to stuff.
So if we do reverse x's equals x's, does that work?
This feels very devious.
But then if we did that, we'd have to have an equality right, on our A. So let's do.
So does Haskell have like a simple conditional, like an if then else?
It does. I don't see it. Well, I say I don't see it. I don't see much production Haskell, so, but I don't see if else used a lot.
Right. I don't see if else used a lot. And part of the reason probably is there's other ways of doing comparisons.
Yeah.
But there's also a limitation to if else in Haskell in that you have to have an else statement.
Mm-hmm.
Forces you to do it.
Yeah. Because everything's an expression.
Yay. So let's try this. I don't know if this is going to work. So what died? Not in scope.
That was the previous example, I think.
Yeah. Okay. Worked. True. Let's try with. Actually, let's just do a couple of them. A, B, C, C, B, A. Let's try. I wonder if Haskell works with Unicode. Let's do. Ni hao, hao ni. I don't know. I'm just grasping at straws now.
Now you're just showing off.
Hey, they all work.
Cool.
Wow, that's amazing.
That's funny. And what if we do it with an empty list? Probably going to return true. And something that's not a palindrome. False.
Okay. I was worried
Cool,
that it was returning true for everything.
Flatten a nested list structure. So
That should be pretty easy, actually.
probably. So one thing we have to do is, here in this example with Lisp, we can kind of arbitrarily nest our lists. But since Haskell is typed, we have to define a new data type to represent our arbitrarily nested list. So let's kind of just play with this guy. We have a new data type, which is a nested list, which contains A's. And that is either going to be an element of A, or it's going to be a list. So the list is this constructor. So it's going to be a list that is a list of more of these guys. So it's like a recursive data structure. So let's try constructing some elements. If we have an elem of 1, oh, well, there's no show. Maybe we can derive show. Let's try that. So if you don't know what deriving does, it basically the compiler is able to sort of derive functions to satisfy this constraint for show. So our function is the show function, which has a constraint that all A's must be showable. And if you give it one of these guys, give it an A, then you'll get a string back. So when we're deriving A, but when we're deriving show, it's basically generating a show function that will turn something of this type into a list. Into a string. So let's try this. Show lm1. Hey, there it is. And let's try constructing a list of, well, we have to give it a list. And an lm1 is a perfect element that we can put in there. We can put another lm2, no problem. Or we can do another arbitrarily nested list. So let's put another list in here. And which has another element 99. Cool. So we have a data type that can represent arbitrarily nested lists. And we need to flatten that thing. So flatten is going to take our nested list. We want it to return a flattened list. Oh, we can do something like this. If what we got was a single element,
Then just put that in the list.
put it in the list. If we get a list of elements,
You flatten both the head and the tail.
well, X's is a list. So we need to.
Is that first list necessary in that type definition?
Here?
No, on your data.
Here?
Yeah, is that necessary?
Actually, yes. So it's kind of confusing, but this here is kind of like our constructor for this type.
Yeah.
So what this is saying is if you supply me, well, if you call this function elem with an A, I will give you a value of this type. And
so it's the type. Oh, that's weird. Actually, it's like a type constructor name.
Right. So here we have a type constructor called list, where if you feed me a list of nested lists, then I will give you a value of type nested list.
I've never thought about type constructors in that way before.
Yeah, they kind of act like functions. It's really kind of neat that in that way. So let's back in the PHCI. Let's go back in. We'll look at the type of elem. Elem is a constructor that you give me an A, I'll give you a nested list. And if we look at the type of list, give me a list of nested lists, and I'll give you a nested list.
Oh, cool.
That's interesting. So can you not define a function of name elem in that module, let's say?
Well, so the thing is, you can't define a function with a capital letter. Yeah, all functions are lowercase. So that's how you can distinguish between functions and type constructors.
Right. I thought we had a list where I can name it literally anything.
Right.
name it the poop emoji.
The poop emoji. Oh god, I don't think I have a way of putting a poop emoji in there. So here we have a list of nested lists. So we need to flatten that somehow. So,
Guys, I just wanted to give you a heads up. I got to step away. But yeah, I thought this was really amazing. I can leave the broadcast running until so you guys can finish up and everything. But yeah, I wanted to say a big thanks because this was really, really helpful.
Awesome. How about this?
Go ahead.
Oh, go ahead.
I was just going to say, I missed name. So we have Gabriel, and who is speaking as functional?
I'm speaking. I'm Richard.
Yeah, Richard, and who's the lambda symbol?
This is Bijan. I was in the Slack.
Gotcha.
Trying to organize everything.
Cool, great. I appreciate you putting in the effort, man. I know I didn't.
No, I was just glad that we got it started. So yeah, I think we could definitely grow from here. So if you guys have any ideas for the future ones or how you want to continue, definitely feel free to send them to me.
Cool.
Right, so I actually kind of have to go pretty soon too. As you can see, my battery's at 11%. I'm gonna die soon. So we can finish up the flatten, and then I think we can call it a day. Is that fair enough?
Sounds good to me.
All right. All right. Thanks.
Cool.
Cheers.
So here we got a list constructor and then a list of elements. So how are we going to flatten this thing? So it's already a list. And then here we have a situation where if we have an element, and we'll just put it into a list. So it kind of looks like we're going to have to do some flattening of something and then concat something else. But what exactly? So let's say the first element in our thing, in our x's, is an elem. Then what we need to do is flatten I think the problem that we have is like this: x and x's. What happens if we look at it from this point of view? Okay. If we think about it like that, we also need to consider what happens if we have an empty list. So if we have an empty list, we're just going to return an empty list. And then if we have a list, we're going to have to return a list of something. A list of something is going to be x.
I think you want to map flatten to each of them, maybe?
Could it be? Is that what we need to do?
So for each element, you don't know whether it's going to be an elem or a list. So if it contains...
Well, the thing is, if we mapped flatten into it,
yeah.
so if we map flatten into our list, x's, then x's is still going to be a list.
Right.
And it might have other lists inside it. So we
can't. Yeah, that's not going to work.
Right? So we need to somehow extract anything that is nested, and so we kind of need to iterate over each element and say like x plus flatten list of x's. Could that be?
Yeah, something like that.
Right? Because x is now, so this here should evaluate to a list. This is a list, this concatenates lists, and this thing is only ever returning lists. Yeah.
Right.
So let's give it a shot. I don't know if this is going to work, but let's see. Flatten, and now we need to construct something. So list with list of elem1. We're doing it wrong. elem1, elem2. And elem3 list of elem4, elem5, and finally list of nothing at all. We'll put that apart a little bit. I can't really tell. So what do we got here? A list of, where's the closing for that one? That's fine. Closer for this one is not there. I think I did it wrong. This should be. After we flatten it, we should get a list of A's, a list of numbers, and then we should be able to print it. So run Haskell, Orlando, let it run. Match expected type A with actual type nested list of A. A is a rigid type variable.
Oh, I think in your, when you concatenate flatten, I think we're.
Oh, well, no, hold on. Right, because X could be another, right, we're talking about nested lists. So X is a nested list, so we need to flatten the nested list.
Right.
We flatten that to turn it into a list.
Yeah, that makes sense.
Flatten the other case. So if we wanted to like make it more explicit, that's LM, and this is list. So we flatten LM, which will just do that. And we can cat with flattening of list. You could match expected type nested list with actual type list of nested lists on line 17. Line 17, column 54.
Right. Yeah, that makes sense.
So list is.
I think we need a
helper
function.
Right?
What's that?
Sorry, what were you saying?
I was saying I feel like we need a helper function here, maybe.
Maybe. So what happens if we map flatten into that list? Oh, but we'll just get a list of lists. Yeah, that's not right. Basically, what we need to do is then somehow extract all the elements out of there and concatenate them.
Right. The problem, I think, is we're trying to recursively call flatten, right?
Mm-hmm.
And only either take a list of nested list or a nested list alone, right?
Right.
So recursively calling on a list of nested lists is never going to work.
No, absolutely not. You're right.
So
that's wrong. I think flatten element is right.
Right. Yeah. But I feel like we somehow need to.
Oh, I think we need to do a concatenation. Can we do a concat? Let me try this. GHCI. Do we have a concat function? Hey, look at that. we have a function that goes from nested lists to lists.
I feel like that might be cheating, but okay.
You might be right. Map Latin to list. Does that work? Let's try it.
Hey,
Hey, that did it. So how would we?
5%. We might want to take that.
You might want to take that. Let's try concat. How would we implement concat?
I think the same problem that we have here is the fundamental problem we haven't solved for flatten, which is you can't recursively call a thing that might be a list of other things,
Right.
and have it be the same function.
So in this case, what we would have to do is say x's plus concat x is this. Is that right?
Actually, that might be okay.
So let's call this concat prime. Just to make sure that we're using a unique concat.
Yeah, sure.
Okay.
Hey.
Hey. Cool.
Groovy.
We didn't cheat.
Awesome.
Awesome. All right. Well, it's been great. Were you here at the beginning when I said that I was going to New York?
I missed all introductions and preambles.
Okay. So yeah. So it's funny because I was like trying to push for like a new, a Haskell meetup, and I think Bijan as well, and some of us as well. And I feel like I didn't know at the time, but I just accepted a job up in New York, so I'll be moving up there in 2 weeks. So
Well, congratulations, and damn it.
damn it. I'm gonna try to continue to show up to the Orlando Haskell meetup or functional programming meetup because I think it's important. I'm originally from here, so it's
Gotcha.
important.
Did you by chance get a job in the financial sector? Because that seems to be the only place that functional developers get jobs.
I tried, but I didn't. And what I ended up getting though was I got a job at a startup in biotech.
Ah, cool.
So they're doing OCaml. So I'm gonna get to be a full-time OCaml developer, and I hope to be able to give back to the community anything that I learn.
Yeah.
So I don't know. At the current moment, I really can't say how much time I'll have because
yeah, sure, of course.
startup hours are going to be insane. But
Yeah.
if maybe what we should do is switch these to like a weekend or something. If really we want to, we can always discuss that on Slack. But
Yeah.
yeah, it's been great, and I'm looking forward to the next one.
Yeah, at some point I'd like to pick your brain because I have this feeling for myself that I want to try to, for my next job, I want it to be something that I don't know well, like functional programming, like getting a OCaml job, let's say.
Yeah.
So something that's for a really good cause. And I'm curious to hear your experience interviewing and so forth.
Oh yeah, absolutely. You can hit
But,
me up on Slack and we can chat.
Yeah, cool, man.
Cool. All right. Well, I guess this is goodbye, and my computer's at 4%, so time to go.
All right, take care,
Thanks,
guys.
Bye.
Take care.